Alright folks, here we have the HS-80 engine disassembly. You'll start by removing the two screws that hold the muffler on. Remove the muffler. Unthread the starter pawl. It's standard thread, not reverse. Quite convenient. Remove the flywheel. You'll need a knocker or a puller. I've already pre-loosened that. Come to the other side. Remove the clutch, also standard thread, quite convenient, not reverse thread. Both ends of the crank are the same thread. You don't see that very often. That's very, very convenient. Undo the cylinder from the bottom, 4 screws. It's usually from the top, this is opposite. Remove the cylinder. Your piston will be attached. I've pre-removed mine for inspection. Remove the 3 screws holding the crankcase together. Again, I've pre-loosened. I use the seal puller. It acts as a crankcase splitter. It shoves in and you can twist it and separate the crank. It's quite simple. But that's what you'll use to separate one half. This is pretty ugly. We're going to separate this other half. We'll remove the crank from this case. Pry your seal out with a screwdriver. And now we'll heat it and tap it out. Should tap right out. Use something soft and blunt. Rubber mallet, leather mallet. Let's have a look at this crank. If you use these things to make money, this is throwaway material. You won't make any money repairing this. These are cost prohibitive. A new crank, a new cylinder, bearings, seals, you would be in at the cost of a new machine. The rod is free. The bearings are seized up. The bearings won't spin at all. Both of them are locked. You can see they're pretty gritty inside there. Not the best. But let's give it a try. Maybe you're snowed in, maybe you're bored, and you want to tackle a project. Let's see what happens. I have the seal puller set up to pull the bearing. Let's give it some heat, see if it'll pull. It's coming. Slowly. We have new bearings we're going to put on. Let's try the same thing on this side. Pull on the bearing, push against the crank. We're going to replace these bearings. I'm not concerned about separating the bearing. Give it a little heat. Now let's try some twisting and tapping. It's going to come right off for us. And there we are. Well, it cleaned up pretty nice. Here's the half of the crankcase. Looks good. Other half looks pretty good. Piston looks fine. Still got all the mill marks, it hasn't worn at all. Rings look good, free. Crank turned out good. Rod is nice. Bearings turned out real nice. We'll look at those next. Let's heat this up and drop the bearings in. One in. Perfect seat. Let's try the other one. Nice and greasy. Nice and cold. Perfect. Dropped right in. Bottomed all the way out. We got the bearings in the crankcase. We have a bearing option, the original OEM bearings cleaned up, or aftermarket bearings. These bearings are okay, but they're full of grit. It all has to be cleaned out. If you rotate it, it'll get stuck on occasion. Right there, it's stuck. Now it's free. Now it's stuck again. Now it's free. Now it's stuck again. This can be corrected by taking it to the laundry sink, blasting it with water, then carb cleaner, brake cleaner, then water, then brake cleaner, then water, and eventually it'll clean out. Oil it up nice and they're actually okay bearings. But by the time you do that process, you probably should have just bought an OEM bearing. Here's that same aftermarket bearing after a trip to the laundry sink. You can see how much smoother it is. There's no hang-ups at all. Very, very smooth. I'll hold it like this and spin it with the cotton swab. It freewheels very easy. Both directions. No snags, no holdups. Very smooth. It's a good bearing, but you have to clean them out. If you use this without cleaning it out, your machine will fail fast. A lot of people on the internet using these aftermarket products, and they say the machine failed within a couple tanks of gas. Well, this is one of the reasons, not cleaning out the bearings. Now we're going to pull the crank through half of the crankcase housing. This side holds the flywheel. The tapered area on the crank is for the flywheel. This is shined up pretty good, but there's no pitting. There's no damage at all. It's just shined and polished up. It's very smooth, very clean. No ruts, no pits, no scratches. We'll use our crank puller for this procedure. This is a homemade device. We'll pull the crank through the crankcase. This is a 5/8 threaded rod with an 8 by 1.25 threaded collar welded on, and the nut spins. Plastic sleeve goes over. We'll thread it onto the end of the crank. This is the HS-80. Both sides are standard threads, not reverse. Push the tube up against the bearing, thread in the handle. This unit can be made, it's pretty simple to make. Just take the threaded rod and weld on your collars at the end. By tightening the nut, it'll push on the inner race of the bearing and the crank pulls through from the backside on the inner race of the bearing. It's a support and pull. Both happens on the inner race. Real safe, real slick way to pull the crank through. Getting close. It's pulling through nicely. You'll feel it gently bottom out when you get there. You can watch the gap here and you'll see it close. Once it seats, unthread the crank puller. And there's the crank through half of the housing. Very nice and smooth. Super smooth bearing action. The mating surface between the crank halves doesn't come with a gasket. This had a RTV on it, so we'll go back and put an RTV back on it and then draw the two halves together. Apply lightly to both sides, and when we join the two halves, the material will come together. If you get any inside the crank, now's the time to clean it off. Use any brand of RTV you desire. No shortage to choose from. Be mindful of the connecting rod and the alignment pins when you pull the crank through. The crank should rotate. All of this should be free. Nothing should be bound up. Align the case halves. Be mindful of your rod and your alignment pins. And pull the crank through. Still good and free. Gap is getting smaller. Alignment pins are aligned. We're still free. And we're there. Nice and free. Take the tool off. And we have a crank installed in the crankshaft. We let our RTV sit for a good hour. Now we'll thread in the screws that hold the crankcase together. A little bit of red thread locker on there. Keep your torque low, number 6 or 8. And finish with the hand tool. Torque the spec. Got the crank in. It's rotating very smooth, nice and smooth, real fluid like, no holdups, no snags. Confirm center with the feeler gauge. Make sure your crank is centered in the crankcase. Notice the thickness difference between the two seals. The OEM seal is on the left, the aftermarket seal is on the right. The OEM is much thicker. Everything is still free and smooth. The crank turned out real nice. This is real smooth, real free. Let's put the aftermarket seal on. I think the OEM seals were $8 or $9 a piece. So we're going to keep it cheap and go with aftermarket. We're getting close. Beautiful. Get you in there and see that. We'll use a piece of aluminum can, piece of beer can. Rainier seems to be a good one. Drop it down. You'll need to leave it on till you get it driven in there a little bit. Pull the sleeve. We have cleared the ridge. This here is the ridge on the crankshaft, this flat spot right here. Make sure the seal lip clears that and doesn't protrude out. We'll finish setting this all the way in. Once the seal's in, there'll be slightly more resistance on the crank. This seal driver tool is nice because it doesn't allow you to overdrive the seals. It'll stop in contact. Take a look at the base gaskets. The HS-80 on top is slightly wider than the 81. Installing the piston, we'll insert the wrist pin bearing. We'll give it some oil. Pay attention to the exhaust orientation on the piston. Insert wrist pin. Install the circlip. A little extra oil on the rings. Install the base gasket. I always use a tiny bit of RTV, just a tiny bit. Make sure your rings are installed in the detent. Use your ring compressor. Install the cylinder, compressing the rings, and slide straight down. Install the 4 screws holding the cylinder on. Here's a good comparison of the two engines. The HS-80 on the right, the 81R on the left. The flywheel mounts different. The flywheel's larger on the 81R. The housing is larger on the 81R. On the back side, you can see the mounting is a little bit different. The 81 uses this triangle shape mount, and the old 80 runs this square mount. If you were going to swap motors, you would be a little bit hard pressed to do so. Install the flywheel, line up the keyway. The coils are mounted on the same side of the block, but the flywheels are different. So the location of the mounting is slightly different between the two models. Use a filler gauge to set the gap between the coil and the magnets. Check for interference. One of the different features about the 80 is that the clutch mounts to the flywheel side. Usually the clutch is on one side and the flywheel is on the other. Here's the intake and carburetor setup. Both of them are quite similar, minor differences. Both utilize a heat shield gasket, an intake, the carburetor, and the airbox. To assemble the carburetor side, you'll take the bolts, drop them down into the intake, flip it over, put the screws in from the other side. The intake gasket on and attach the intake. Gasket that lines up with the pulse ports, carburetor, outer gasket, shield, air box, air filter, and cover. Install the muffler with 3 screws. A third is hiding down in here. Another difference is the muffler. The HS-81 utilizes the traditional 2-bolt muffler and gasket and is a lot smaller. There's a 180 degrees difference between the two models. In the resting position, these are intended to be vertical shafts with a horizontal piston. Chainsaws in the resting position are a horizontal shaft with a vertical piston. The biggest difference is the flywheel clutch arrangement. On the 80, we have the flywheel and the clutch facing down. On the 81R, we have the flywheel on one side and clutch on the other. This is the more traditional method. Both clutches point downward, so the motors sit exactly 180 degrees from each other. We'll take a look at the gearbox. This is the HS-80. It has the equivalent of a chain brake, like a chainsaw, operated from the handle, which operates this lever. We'll flip it over, take a look at the gears. Move the gasket. This gasket needs to be replaced. Remove the cutting bar with these 2 screws. Lift off the gears and the bar. The component arrangement is the same between the 2 models, but the gears and the rods and the components are not interchangeable, but the layout is identical. Remove the gear and the connecting rod, gently pry it up. The HS-80 uses a solid connecting rod. The 81 has needle bearings inside here. So if you're doing the 81, be mindful that there's needle bearings that can come out. This is all new grease. I'd cleaned this out and repacked it. To reattach the cutter bar, we're going to rotate the bottom connecting rod to the lower position. We'll line it up to the center. There's one stud here to hit and one detent on the cutter bar to hit. Align the detent first and then rotate the gear to get the connecting rod to drop in. Put the top connecting rod on. Light rotation. Put the top sleeve on. Tangs down. Make sure the support grommet's in. We'll put a new gasket in. OEM's the only option. Aftermarket wasn't an option. Reinstall the 2 screws that came out. Reinstall the top cover. And that's a completed gearbox assembly for the HS-80. Your only option for gearbox parts and gear housing is OEM. The aftermarket gear is about a 1/4 inch too tall over the OEM gear. The aftermarket rods are about a 1/4 inch to a 1/2 inch too short than the OEM rod. To assemble the gearbox, we'll drop in the friction sleeve. We'll attach one rod to the gear. Drop the gear in the housing. This is the HS-81. It doesn't have the rounded face gear. The HS-80 did. We'll connect the cutter bar. Screw holes are at the bottom of the stroke. There's a bushing that goes in underneath the bar support. Second screw with bushing. This is a long one. Upper connecting rod. Rotate the gear. Support bushing. Upper shield. Gasket. And cover. Six screws. And that's an assembled gearbox with the bar attached. The aftermarket clutch doesn't fit either model. It's the same diameter as the 81, a little bit smaller than the 80. The aftermarket is this 2-piece, and it doesn't fit either. It says it does, but it doesn't. For assembly, we'll start with the handle from the rear. Take a look inside the throttle control. We're going to install a new throttle cable and a new tilt handle. It's just about ready to break right here in the middle. The new lever doesn't come with the spring, so save your old spring. We got 4 T20 self-tap screws to hold the handle together. The O-ring sits inside the groove. We can remove the sub handle and put on the throttle handle. Install the locking clip. Check the pivot. Install the sub handle. The throttle cable goes to the left. The bar brake goes to the right. One self tap on the bottom holds the sub handle on. We'll feed the brake cable through. Make sure it sits in the slot. Seat it in. Make sure the clutch is spinning. Nice and free. Blades are working. We'll hit the brake lever. Clutch is locked. Blades won't spin. Free. Spins. Brake lever. Locked. No spin. Safety features. We'll put the front cover on. It should snap into place in the front. 4 screws. They're a 4mm. We can drop the motor in. There's 2 pegs that'll line up. 3 screws come in from the bottom. These are M5s. We'll hook up the kill wires to the coil. There's a small slot in here and another slot up front. This one's pretty deep, you'll probably need a pair of pliers. The gas tank needs new fuel lines. We gotta pry these off and replace them. Barely can blow through that. Clean out the tank and the fuel lines. We'll remove the air housing to install the fuel lines. Let's put the fuel tank back together. I got some new fuel line. It's 3mm by 5.5. I stock all 10 sizes. Guess that's not all the sizes. All 10 is all the sizes I have. Tiny bit of grease. This is the vent line. The return line, fuel filter, tiny bit of grease, align the flat spot with the flat spot here. Work it on there nice. Don't let your big fingernails cut the line. We're using some of Rotary's Tygon fuel line and a Rotary product for the actual fuel line. We got a vent line and a fuel line, or a fuel line and a return line, more appropriate. The inlet closest to the purge bulb is the return, so we'll hook the Tygon line up to that. And hook the fuel line up to the bottom inlet. The fuel tank is a structural part of the handle. It has the metal cleats in here. The screw comes up through the bottom, through the handle, and locks into the fuel tank. They'll stay secured down here in the rubber anti-vibes. I hope mine are still in here. Much more rigid now. Going to mount the throttle cable now. Sits inside a small track. I have the carburetor loose. It makes life a little easier, mainly for the fuel lines. Feels really nice. We'll re-secure the carburetor. I gave it a carb kit when you weren't looking. I stocked the rotary carb kits. We did a new metering diaphragm and a pump diaphragm. We'll do a rotary spark plug boot. I prefer the clamp-on style the best. It gets a real good connection, real solid, lifelong. I'm not a fan of the little pokey style it comes with. Now that's a lot better over this little doodad. Much more solid. Won't pull out when you're changing spark plugs. We're running out of parts to put on. Install your spark plug, put your plug wire on, secure the plug wire down here in the connector slot, secure the ignition wire in its slot. The cover goes on easiest with the air box removed. So I removed the air box. .5 millimeter screw holds the front cover on. And then the pull starter. 3 screws, and we're ready to go hedging. Well, it feels like it's really good. It's got great compression. I think we have a good cylinder and piston. If not, we'll try our luck with an aftermarket cylinder and piston. A Lombo. Well, for the HS-80, the actual repair was 2 crankcase seals, a carb kit, and a new throttle cable. The bar was in great shape. Everything else was in great shape. Clean out the crankcase, clean out the bearings, and it was right back together. Started up real easy. It was the first time it had started in years. Let's give it a cold start right now. cold start. Fires right up. Once you have your gearbox and engine assembled, it's pretty easy from here. Start with the 2 springs in the front, the 2 springs in the rear with the rear support, locks them down. The rear support is OEM only, the springs can be found aftermarket. We'll attach the exhaust header. We're going to do a test fit with the motor to make sure the exhaust header aligns with the muffler. You're looking for a tight fit right here between the exhaust header and the muffler. We'll install the under support strut. The assembled handle goes on and is attached from the bottom. The lower strut bar goes on underneath the gearbox. Line the springs back up. Mount the strut bar in with the 2 screws. Exhaust tube goes over the lower strut rod. The springs have their own channels to mount into. Make sure you have them locked in. Secure with the pan head screws. Both of these rear mounting pieces need to be purchased from the STIHL dealer. They're both OEM, neither available aftermarket. It mounts on nice and strong. The handle feels really secure, mounted to the gearbox. Blades are nice and stiff, it's nice and firm. The springs are nice and stiff but allow just enough play, just enough anti-vibration. If you wanted to remove the gearbox and the cutter bar as a unit, you would remove the rear springs and mount, the front springs, and the 3 screws that mount the gearbox to the motor. The gearbox and cutter bar should then come off. If it doesn't come off, your clutch is bound up. You probably have corrosion and rust on your clutch holding it together. The lower engine housing rests right inside the cradle, held in by 2 pan head screws. Next, the engine should drop right in. It should line up directly with the cradle. Held in place by 3 T25 semi-self tappers. Feels nice and solid. We'll connect the fuel lines, the throttle linkage, and the ignition wires. Pretty self-explanatory. The long one goes to the far side, the short one goes to the short side. The lines are about 1 inch too long, so we're going to shorten them. The throttle linkage and ignition wires come up above the carburetor and through a slot through here. It'll come around the top channel and latch to the carburetor linkage. Ignition wires route through these top clips. They should sit in there neatly like that. 1 coil wire attaches to the coil. They shorted us a part. The other wire just goes to ground. It can go to this screw, but they gave us the wrong terminal. We're gonna have to make us up a new terminal, something like this to attach to. Reset the gap with the filler gauge and attach the wire to the new terminal. Install the spark plug. It's a CMR 7H. Install the boot. Install the top cover. Five screws hold the top cover on. There's 2 self tappers that hit the plastic and 3 M5s. Install the front handle. 2 of the large self-tappers hold it on. We need an air filter and the air filter housing. Here is a side-by-side, near identical. If you're like me, you want to know how it runs. Let's go see if we can find something to hedge. We'll go take care of some hedge funds. We found an air filter. Good snug fit. The cover needed a little attention. It fit like OJ's glove, but now it's pretty good. Well, I think I found us something to prune. This last row right here. The sun was out a minute ago. Golfers were out and everything. Now it turned back crappy cold weather. Let's prune these. Well, what do I think of the 81? It's an exact replica, an exact clone of the STIHL HS-81. For the 2 minutes I ran it, it ran fine, ran good, performed well, felt good, starts good, shuts off good, everything seems to be a winner. Tilt handle works. Break-in was the same. I ran 50 to 1 through it, ran it a little rich. a full good tank of gas, a couple of heat cycles. I think I did 4 heat cycles. Warm it up and then cool it down. Some of the cons: the fuel tank vent leaked. Simple fix, pop it out, through a new one in. I gave it the breathalyzer test. It vented both ways, so it was bad. It needed to be replaced. The air box fit like OJ's glove. Needed a little touch up with the file. Now it's just fine, goes on and off just fine, real smooth. The cutter bar is very sharp, seems very good. The thigh guard is a nice feature. The tip guard is a protector is a nice feature. Let's do a cold start. Sounds good to me. Cost? Can you save money by building it yourself? Not really. I came out 20 bucks cheaper, and that's not saving much. You would be better off buying a brand new one from the dealer. I'll show you all the parts and price breakdown next. Here's a list of the aftermarket parts that are available. Prices have gone up quite a bit. I bought all my aftermarket parts about 2 years ago. They were significantly cheaper. All this costed me about $150. Today's price with the current price increase is $216.97. Here's your parts list and parts number. And there's your total. $30 less than a new machine. Wow.